So welcome everyone, and piggybacking on your idea, I had just heard that JavaScript was sent to space. I'm wondering if it came back.
It did, unfortunately.
All right. All right, so I hope you can hear me just well. The projector wasn't working, and sorry for switching of the agenda. It's my fault, but I hope you enjoyed all the talks anyway. So, this doesn't work, but we'll get to it. Okay, so without further ado, so let's say it's your first day at work, and your manager comes in, and he kind of thinks he's kind of a developer himself, and he walks by and has this amazing idea, or actually it's a very simple task, at least that's what he thinks it is. So he would like you to implement kind of a piece of backend, small, tiny functionality. And the idea is that whenever someone registers to your website, you send a registration email. That's great. But if someone doesn't click on some sort of a confirmation or whatever in that email, you wait 24 hours and you send a reminder email. That sounds simple. You send one email, the server waits 24 hours, and if there's no activity, just ping the person again. And the manager kind of thinks he's a developer to the point that he even vibe-coded the solution. I'll back so that you will see it. It's not particularly complex, as you can see. So you just like the first step, send registration link for a given user. Then you sleep for 24 hours. Sounds simple, right? At least that looks like very primitive to the manager. And then if the user didn't register yet, you send a reminder link. Fair and simple, right? That's kind of a skeleton or a framework or a pseudocode, if you call it. Okay, so I actually took that code because it was vibe coded, and apparently the manager thinks that it's pretty much ready to ship. So I vibe coded it. So here it is. You see the code? You see the code. Bigger. All right. So here's the exact same thing with sprinkled with a bit of async awaits, whatever, because we're talking TypeScript here. And okay, I changed sleep from 24 hours to just 5 seconds. I hope you can live with that. I'm just gonna knee in front of the computer to do some coding. Okay, so here's my code, and what I'm gonna do, here it is. Yeah, we have some animals here, and I'm gonna pray because it's a live demo. You're absolutely right about that. All right, so what I'm gonna do, I'm just gonna clear up the screen, and let's just run this and see whether that code works. I mean, it would be really weird if it didn't, but anyway, so I'm gonna start the server. The server is basically something that runs this function that you just saw, right? So I have a piece of Node.js server which runs this code, right? So that's one thing. And the second part is that I will just ping that server and ask it to run that functionality. So I have a tiny little run workflow, and you're only interested about the bottom part. And it's so low that I'm gonna make it easier for you. For the people in the last room. Yeah, I will actually switch, or I will switch in a second. But you're asking me about the chair? No, I think it's funnier when I'm just kneeling in front of it. All right, so what I'm gonna do right now is that I'm gonna run the workflow. And hopefully you're gonna see something on the bottom sooner or later. Why are you hanging? That's why I was praying. Oh, I'm in the wrong folder. Yeah. Okay, I have a few uncommented. This time it should work, and you should see something. Oh, thank God. Right, as you can see, my 3 lines of code. You don't see the bottom line. I will switch the windows in just a second. All right, so it worked, right? Oh, I'll make it easier for you. Or you will have to knee as well to actually see it. Sending a registration link. What is really important is that 5 seconds later, or 24 hours later, there's checking if the user actually registered, and then they're sending a reminder link. Right? Can you tell me if there's something fishy or something that you don't particularly like about this code? Let me just move on to the real deal written by the developer. Can you tell me if there's something not particularly sound in this snippet?
What if the server crashes?
Absolutely, and a ton of other things. But yeah, thank you. So, what if the server crashes? Thank you. We don't know each other, but I'm really glad that you said it. But there are a few other things. I think I'm just going to stop kneeling here. So what if, actually, sleep takes some resources, very little, but it still takes some resources. There's absolutely no resiliency. So what if sending an email fails? Or what if we use some API that takes, I don't know, half a minute and we don't have any timeouts? And it's absolutely untestable because it's hard to test code which sleeps for 24 hours. It would be kind of a bit of wasteful. So this is where Temporal comes into play. It still doesn't work, or it's not mine. It's not mine. I just flipped the page on someone's computer, sorry. So Temporal, and do not confuse it with the Temporal API because this talk will be totally backend related. So Temporal is a workflow engine and it sounds really scary, but essentially it's a piece of infrastructure or a piece of code, an open source solution, which sort of allows you to think as if your server was running forever. So even though, as you perfectly said, the server can crash, and if the server crashes, I don't think we said it out loud, if the server crashes, it doesn't mean that the process will be interrupted, or it will might not happen on time. It won't happen at all, right? Because this is all in memory. So even if we restart the server, it has no memory of that process. It's kind of obvious, right? So no point in even mentioning that. But Temporal gives you the illusion that that's not the case. Even if your server crashes, even if your server was down for several hours, if you put it back up, it will continue with the process, right? So even if your function, which contains several steps, even if it crashes somewhere in between, somewhere in the middle, it will restart in the point where it crashed. So in some sense, the pattern is called persistent function or persistent procedure, if I remember correctly. But the basic idea is pretty simple. Let me get straight back to the code. If the code crashes at any of these steps, so sending registration or the sleeping is interrupted or whatever, when the node restarts, it will automatically pick up. Or even better, if you have multiple nodes and one of them crashes, another one will continue. And it just happens seamlessly. I don't mind questions, or I don't mind interrupting. So if you have any, feel free.
State. I mean, if you fix the things and redeploy it.
Once again?
If you fix something and redeploy it, how it will catch up?
Okay, the question is, what if I fix something and redeploy it? So if you change some of the implementations in the workflow, the steps which did not yet execute will just use the new code. If the code already ran, that's it. That already happened, right? Versioning is a completely different issue, but let's skip that for a second. All right, let's move on to get back to the presentation. So technically, because workflow sounds very heavyweight, and there are plenty of workflow engines out there, cloud offerings have workflows and etc. But the thing is that pretty much every non-trivial piece of code out there is a workflow. So if you have a process that takes several steps, if you have conditions, loops, if you have something that is long running, so we have an operation that takes several steps and it can span multiple minutes, not because it sleeps for 24 hours, but just because it has multiple steps. In all of these cases, you can say that it's a workflow. Now, it doesn't really help with anything. I'm just trying to convince you that things like that are in your code, and most of them are just implicit. So let me give you a few examples, and I'm specifically aiming backend development, but your front end can still trigger some workflows which are running for a long time on the backend side. So microservice orchestration, again, sounds scary, but basically a bunch of services calling each other and fulfilling some longer process. Queues, webhooks, everything that is possibly long running, everything that can possibly fail, everything that needs to have some sort of resiliency built in. So if it fails, it needs to be retried, restarted, it needs to have timeouts, and so on and so forth. Yeah, so talking about resiliency, and let me give you, because I was showing you this really naive example, and I will flip the windows very quickly without actually terminating my whole terminal. Sorry for that. Didn't expect that. All right, so just to convince you that it works, and then I'm going to give you an even better example. So I'm starting the server again. Okay, here's some server doing something that doesn't really matter at the moment. And at the bottom, I will just start the process that I just interrupted. So let me go again with one here. And I'm starting the process. Remember, the process was the sending email, registration, blah, 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 blah. Okay, I started it already. Giving some space here. It actually start. Oh, I started the wrong thing. npm run workflow. That's what I wanted to start. You should be looking at the panel at the bottom. Sorry, at the top. Okay, it's still too low. Sending registration email. It should take about 5 seconds.
Change it to 24.
You did change that.
Okay.
You actually changed it to like.
I think we have time, right? Okay. Very good point.
86 floor.
Let's go with 5 seconds. And actually, this change won't be reflected in the workflow itself, right? Because the previous one already started with a different timeout. It might spit some errors, but anyways, we're doing live coding anyway, so let's try it. Okay, so here we have the server at the top. Let's run the workflow again. It's going to be a second workflow. Hopefully this time it's going to trigger after 5 seconds. Okay, so as you can see, you can even see some time steps here. It worked, but that wasn't the point. You already saw that. So let's run the workflow again. Okay, but this time what I'm going to do, okay, the workflow has started. I crashed my server, right? So now the server is not running. So there's no physical node. There's no physical worker for actually running my code. And okay, let's have a chit chat for a few more seconds. Now, the bottom line is that if I now restart the server, so if I now run it again, so now I'm restarting the server because I don't know, I was doing an upgrade, I was migrating to a different node, auto scaling, whatever. So I'm restarting the server, and yeah, you know what's going to happen. Here it is. You see, there is no sending registration log because that step already happened before I restarted the server. But after restarting, it figured out that there is a workflow, and that workflow was supposed to trigger after 5 seconds. It's already late, but okay, that's fine. And now I'm sending the, now I'm invoking all the remaining steps. Do you see what happened here? This is actually pretty big. Of course, I can run the workflow again, but that's not the point. Okay, so now let's move on to something a little bit more interesting, because it's not only about shutting down the server. It's also about adding the temporal, is also about adding quite a few guardrails when it comes to resiliency of your process. So I have one process which is very similar. It's called D2. But these functions, and by the way, my process consists of these like I won't say pure, but very simple functions. Like each one of these functions is just logging something. Imagine any of these functions just doing a database call or a RESTful API or whatever, like whatever it takes, right? So I'm just wrapping my business operations in these functions, and there's nothing particularly exciting about these. What I added in this example is that once in a while the activity will fail, and also some activities take excessive amount of time. And I do have a configuration that if it takes too much time, or that's what Temporal gives me kind of by design or by default, if the operation takes too much time, it's just going to be terminated and retried, because why not? All right, so I have this example, and just as a quick reminder, the previous one was much simpler, because the previous one, where is it here? The previous one had no like simulated errors. It was just like do the stuff, log the stuff, and move on. All right, so here's another one. So here's the one that I wanted to show you right now. So let me quickly move on to the other one. So I'm going to start the worker. Come on. npm run start watch. So this is my server. This is the thing that's going to run my application code. It's running right now. And here is the example. So I'm going to initiate that workflow. And by the way, the workflow itself, so the function that kind of orchestrates all of this, is extremely simple. Close this one for now. So the function that orchestrates the whole thing is extremely simple. You don't see any kind of infrastructure. You don't see any frameworks here. You're just calling functions. So these are the same functions that you saw here, right? So I just have a piece of logic which invokes like lower level functions. That's really helpful. All right, let's run it. So here's what's going to happen. I'm going to now run the workflow, and there are going to be exceptions on the top screen. That is kind of by design, so don't laugh, right? So I'm starting the workflow, and here's a first failure. I'm going to make it even more visible. It says random failure for it's simulated, right? So it just keeps retrying. Okay, it finally managed to send registration link. So as you can see, there were some failures, but it eventually managed to complete. They're sending reminder link, and it tries to send reminder link again. Do you remember why? You'll have to know the code by heart. I will try to help you with that. So
Excessive time, right? Excessive time.
Exactly. Wow, you're really have a really good eye. Yes. So the registration link was failing very frequently. Actually, 70% of the cases it was failing. And the sending reminder link doesn't throw any exceptions, but it's excessively slow. Right? Of course, the threshold after which Temporal decides that the function takes too much time for execute is configurable, but I'm just using some sort of a defaults. All right, but eventually, as you can see, the workflow managed to execute. There are no try catches here. There are no timeouts. There is no promise.race. There is no whatever. There is no orchestration. You just have like this is your entire business logic. This is almost exactly what your manager wrote in the first place, right? It just worked. So there is no infrastructure code that pollutes your workflow. So I think it's actually a pretty brilliant idea. I did some screenshots because I didn't know that whether the projector is going to work. So I think it's about time to actually look under the hood how it works. I really like this. I think I'm just going to stay this way. Let's peek under the hood. And by the way, what you saw there was an example of a process where you have like a single function which has several steps. They are fairly heavyweight. Every step of that function can actually fail in some unpredictable way. So what you really want to do is like have some sort of a safety mechanism so that you don't have workflows which functions, right? A function calling another function, which just hang forever or have no error handling, in which case every step can basically fail the entire transaction. Okay, so I think it's about time to actually look under the hood. So there are a few things that we never covered, or I was actually hiding from you. So there are a few components, or actually there's one which I have never shown you. So there's worker. So worker is essentially the thing at the top, right? So this is your application. Your application has your code, has your database connection, has your APIs connecting to your microservices, and so on and so forth. This is your kind of business flow. So that's one thing. The other thing that I have not shown you yet is called the temporal server. And I'm going to refresh it so that you will see some things are still running here, but wherever I think this one is completed. Oh, I know why they are still running. You remember? Because I forgot to do a sleep off. Tomorrow at 7 p.m. These were actually complete, but that's cool. All right, so here I have a workflow. I'm gonna make it bigger for you. Maybe too big. So what actually happens? There's a fairly big component called temporal server. And the temporal server is the orchestrator of the workflow. And it all happens behind the scenes. And I will show you in a second how our code was actually connected to this guy. So what happens under the hood is that the temporal server is like a transactional log or a write-ahead log or a ledger, which remembers every step of your workflow, right? So it knows which pieces of your workflow, which functions within your workflow were already executed, and what was their result, right? So they keep the entire kind of history, like entire audit. That's why you can see this nice little waterfall example here, and you can actually see like sending registration link. Then there was a sleep of 5 seconds. Then there was calling is registered, and then sending reminder link. Maybe you don't remember, but the thing is that the function started here, but it wanted to start here. It didn't because the server was down, right? So the temporal server doesn't really run your code. It just knows that some code needs to be run, but it waits for your worker, for your node to come back online, which is a pretty cool functionality. So anyways, you have this server, which is sadly the single point of failure. You need to have it. And under the hood, it has a database and it has all sorts of APIs. And your application basically transparently interacts with that server, and it notifies the server about the progress and asks for more steps. That's why when the server goes down, when your node goes down and it comes back up, it just picks up where it left off. The way it works is a bit convoluted, but it just works. So let's assume it just works in this short time span. That's also the reason why, and we'll see a demo like that in just a second, that's also if you have two nodes, and this is just mind-blowing, if you have two nodes, and one of them starts, 1,000 workflows, so 1,000 functions having multiple steps, the workload will be equally divided onto these two nodes because both of them will be asking the temporal server, is there any work to do? So technically, it's possible that you start a workflow on one node and then it transparently moves to another. This is also a great opportunity for auto-scaling. If you have too many workflows running concurrently, just start more nodes, and these nodes will just pick up the work from one global queue. So I hope you're now wondering, so how on earth is the client connected to, or worker node is connected to the temporal server? And there's a bit of magic, I'm not gonna lie. So the magic lies here. So here's our workflow. And I even hid the top part from you. And I have a workflow function, and it has a bunch of functions which it calls, right? But I don't just import these functions from this different file. So these functions, this business logic, basically. These functions are called activities, but that's not important. These functions, I don't just import them straight, and I don't just call them. But what I do instead is I use this piece of a glue code, which I'm not gonna fully explain today. But the basic idea is that when I'm calling this send registration thing, I'm not calling the actual function. I'm just calling some sort of a proxy, and that proxy consults with the temporal server whether it should run it, or maybe it already ran, and the results are already stored. By the way, that's how Temporal can restart the process from the place it crashed rather than from the very beginning. But anyways, this is for the purpose of this demo. This is all you need, right? This is all the boilerplate you need in order to turn your normal like TypeScript function into a persistent function which knows where it stopped, which is capable of retrying, restarting, and so on and so forth. Moreover, if one of these functions, for example, send reminder link, remember this one was particularly slow, but because it's wrapped by Temporal, you get try catches and you get timeouts for free. It just works, right? So it will restart the process for you. So that's one thing. This is just some boilerplate configuration. You don't really have to bother about it. The second part that you need to do, and it's not particularly invasive, but it is a little bit, but not really that much. You cannot just run that function. The function is called workflow2. You cannot just run it directly. Instead, you use the Temporal API. So the Temporal API, you ask the Temporal API to run your workflow with some parameters, and that's it. The rest is just boilerplate. So that's it. So it's not totally transparent, but it's close. If you ever worked with any other workflow engine, I'm really sorry for you, that's the thing. But secondly, they are pretty heavyweight. So sometimes you have to draw the workflow. You need to use some special language. For example, you define your workflow as a directed acyclic graph in, what is this thing? Airflow, right? You use Python and you define your workflow in Python, and then it calls other operators. It's a nightmare. Here, you just have a normal function, and maybe this is what you already have in your code, right? Maybe you already have a function like that. You just didn't think about resiliency, you didn't think about retries, whatever, blah, 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 blah. And now you need to have them because your server crashes and your process is lost. All you have to do is just wrap your functions in Temporal and run that function, the workflow2 function, in a slightly different way. Any questions? Feel free to ask questions at any time, by the way.
What happens if the temporal server fails?
And then
Then
you're out of luck.
This process running on the port 733. This is a temporal server, right?
Yes, this one, yes. I intentionally didn't mention on it, but yes, this is the temporal server running somewhere on my machine, and it needs to be alive, right? You can scale the front ends of that thing, but if the underlying database is down of temporal, because there's a big ass database which stores all the ledger and all the history, right? If that one's down, sorry, no workflows for you. Technically, you could fall back and just call that function without temporal, hoping for the best. So you no longer have retries, persistence, and so on, but you still have code which runs your function.
But if you need to catch the error,
you still can. So you can do try catch, and you can tell Temporal that some errors should be propagated rather than swallowed.
like after retries.
Still possible. Yeah, that's still doable. And by the way, the previous question was what if the temporal server is down for the purpose of the recording? And the second question was what if I actually want to catch the exception? It's configurable. So some types of exceptions can be propagated rather than swallowed. All right, so here's your thingy. And I actually wanted to show you one of the workflows. Or you know what? I will start the workflow. Oh, I was supposed to be crying here. So this is the workflow that fails, right? So it had like lots of retries and lots of timeouts. And let's just look at it in real time. Okay, this is our process. And you can see here attempt 4 out of, okay, it already succeeded. Way too early. Now we're waiting 5 seconds. Okay, I was unlucky and everything succeeded, believe it or not. So let's try again. I wanted to show you how I'm losing my voice for some reason. This one is running. Okay, attempt 6 out of 10. Okay, you would have to be really quick, sorry for that. But again, you see that the process is going and send a reminder link. There's attempt 1 out of 10. It tries again and again, and it's finally succeeded. So you have not only an audit log of which actions run, but also about each failure, which is pretty cool. Okay, I wanted to show you, I think, one last demo. And the one last demo will be a little bit more complex, but I think it's a cool thing to have. So, or a cool thing to know. So here is our more complex workflow. So too old for this. So what happens here, please zoom in a little bit, no. What happens here is that I have a bunch of, this is my workflow, right? This is my function with a workflow. So what I do here is that I have a bunch of users paying for my product, right? I'm a software as a service company, whatever. This list can be one user, but it can be 1 million users, right? And I would like to do the following. And the pseudocode is actually all you need. It just works, right? And there is no like extra safety nets that are required. So what I'm doing here is that after getting the list of all the paying users, it's either 10 or maybe 10 million, whatever, I'm generating an invoice, which can take time. It's like CPU consuming and so on and so forth. I'm storing it on S3, so I'm storing a binary on some cloud storage, whatever, and then I'm sending an email. That's my entire process. This repeated 10 times or 10 million times, right? So it's definitely a long-running process. Okay, you see the idea of this code? All right. The implementation of these steps is actually irrelevant, but they are sometimes failing, sometimes slow, and so on and so forth, right? I'm just simulating the real deal. So let me, the demo requires kneeling. So let me run it, and we will observe how it behaves. Okay, running the server again. Start watching here. And what's going to happen, right, it's already running, but that's not important. I have some pending process, whatever. Let's just wait until it finishes. All right, and I'm wondering how many paying users I have configured. Only 5. Okay, so the workflow is going to be fairly quick. Okay, this one is done. I'm just going to clean up this screen a little bit. So what I'm going to do is that I'm going to run this function. And run workflow, and enter. So you will see very quickly that there are some errors. These are simulated, so don't laugh. And it processes foo1, foo2, foo3. So all these customers are subsequently executed. When looking at the actual workflow, I think it's still running. It should have completed by that time. Maybe it's not this one. I don't think it's this one, but whatever. Okay, so let's start it again. I have a full picture. So running the batch again. Okay, here it is. So now you can actually watch in real time how it goes through these steps, and it iterates over the customers and like generates the invoice, stores it, sends it, generates, stores it, whatever. I hope you can imagine that this tiny little function could actually take several minutes or even several hours. So obviously, no one's gonna implement it this way, right? A simple loop over whatever the database returned. That's just insane, because if it crashes in the middle, we have no track of what was already executed and what not. So if you're unlucky and you're one of the first customers and the process retries, you will just keep getting invoices over and over and over again. If we implement it this way without Temporal. With Temporal, on the other hand, and let me just run the same workflow. With Temporal, I can run it. As you can see, the process already started, so it's somewhere halfway through. Now I'm going to crash it. Crash. Okay, the node is down. Obviously, the process will be like hanging. Okay, it's still here. It says it's running, but it's not running because there's nothing. Oh, you see, it's preparing an invoice, attempt 2 out of 10, but there's no server to actually run it. So let's run it, right? Let's run the. Oh, I didn't want to run the workflow. I wanted to run the. Start. Okay, I'm restarting my node, and it immediately picks up the work when it left off, right? So if we now go back to the screenshot, as you can see, there's a huge gap. Nothing was going on because the server was down, and then it just succeeded. I hope it succeeded. And one last demo for today. Yeah, I'm running out of time.
Yeah, absolutely. You have my negative 10 minutes left.
Start working.
Okay. One last demo. Okay, so what I'm going to do, sorry for that, guys. I'm going to start 2 nodes this time, or actually just one at first. Negative 10 minutes. All right, so on the left-hand side, you see a server running, and it picks up the work. But what happens if I run the second server, and if I'm quick? I wasn't. Okay, now let me start again. So starting the workflow again, and what you will see is that both of the nodes are actually splitting work. So one of the servers takes parts of the workflow and another node takes some part of the workflow. If I have 3, they will all equally share the work. If I have just 1, it will be lagging, but it will do the work. Thank you very much. And sorry for the
All right, questions?
question.
So,
Let's yeah.
what is the biggest food gun for the temporal from your
Oh, plenty. So the abstraction of a persistent function is actually very leaky. So if you, for example, if you change the structure of your workflow and you already have some workflows running, it's gonna crash. The question is, what is the biggest food gun, or what are the biggest drawbacks? So that's one. Second, you have one temporal server standing in the middle. If it goes down, your entire application cannot run any workflows, and so on and so forth. There are actually like plenty. Your one of the biggest one, I believe, the biggest one, and not that obvious, is that your workflow needs to be very predictable. So you cannot just change your mind midwise and like completely reorder the steps or add steps if you have some workflows already running, because the server will get really confused. Right, thank you. And you were second, and you were third. Yeah.
I just have a short question. Could you show the process of like wrapping the function in this temporal thingy? Because you just show functions that were unpacked, but
So here's the process
How
of
the-
setting. Yeah.
how is it like applied upon the function? So I import functions from somewhere, right? How
Yeah.
do
So
you set the temporal?
the functions actually live in the same directory. So here are my functions, which have no notion of temporal. I believe there are no imports from temporal whatsoever.
Mhm.
The workflow is also free from temporal, so there's no temporal code here in the workflow. However, you don't just import star from functions. You do using the proxy activities. This is actually the file of with your functions. So there's a little bit of blue code here, but it's like almost invisible, right? You use the functions the same way and they're still statically typed and so on and so forth. It just works.
Just all the way down.
Thanks.
Yeah, it's very magical.
It looks
Coming
magical.
back to the question of what are the biggest drawbacks. This is very magical. Yes, and last question because
How many resources does temporal server take? Like, what kind of cloud instance would I need to self-host it?
it runs on my machine. It's a database, and you need either a relational database like MySQL, Postgres, or Cassandra, and you need a front end written in Go, so it's fairly lightweight. And the server itself doesn't run any code; it just orchestrates. So it just publishes like what kind of tasks do you want. Right, I really need to stop. So thank you very much again.
Warsaw.